Good morning, students. Today's COVID appropriate behavior is keep maintaining physical distance of 6 feet or 2 yards. Let's start today's worksheet. Worksheet number 69 and today's date 18/12/2020. Topic is Law of Conservation of Energy. Jigyasa Didi, we now know that energy in one form can be changed to another form. But what happens to the total energy of the system? Whenever energy gets transformed or changed from one form to another form, total energy remains unchanged, means constant. Total energy remains constant, that is kinetic energy plus potential energy. Mechanical energy remains constant. This is due to law of conservation of energy. So according to this law, energy can neither be created nor be destroyed. Energy can neither be created and nor be destroyed. It can only be transformed from one form to another. Transform from one form to another. And this is called law of conservation of energy and is valid in all situations and all kinds of energy transformations. For this, let us take simple example. Let an object of mass m made to fall freely from a height h. This is the object and this is the height h and the mass of the object is m. This is the ground level. At the start, the potential energy is mgh and kinetic energy is 0 because its velocity is 0. So at the maximum height per potential energy is maximum. This is the gravitational potential energy which is equal to mgh and kinetic energy is 0 because at maximum height the velocity of the object is 0. So that's why kinetic energy is equal to 0. Thus the total energy of the object means potential energy plus kinetic energy mgh plus 0 is equal to mgh. So the total energy of the object at height h is equal to mgh. This is the first point. Next, as it falls, when the object falls down, its potential energy will change into which energy? Kinetic energy, because the body is in motion now. So as it falls, the potential energy will change into kinetic energy, means potential energy decreases and kinetic energy increases. So if v is the velocity of an object at a given instant, so the kinetic energy will be half mv square. So as the fall of the object continues, the potential energy, as the fall of the object continues, potential energy will decrease and kinetic energy will increase. Next, when the object is about to reach the ground, this is the third case. First case, when the object is at height h. Second case, when the object falls down. And third case, object is about to reach the ground. In this case, at height h, and now h is equal to 0. Near the ground, height h is equal to 0. Its velocity will be highest. Now its velocity will be highest. At maximum height h, velocity is 0. At ground level, velocity will be highest. So, potential energy near the ground is 0 and kinetic energy is half mv square. And during fall, the total energy is equal to, in this case, total energy is equal to mgh plus half mv square. So in first case, total energy is mgh. Second case, total energy is mgh plus half mv square. Potential energy is decreasing, that is mgh, and kinetic energy is increasing, that is half mv square. And in third case, total energy is half mv square. Because h is 0, so potential energy is 0. Therefore, the kinetic energy would be the largest and potential energy will be least when the object about to reach the ground. However, the sum of the potential energy and kinetic energy of the object would be same at all points. That is, potential energy plus kinetic energy is equal to constant mgh plus half mv square is equal to constant. Sum of kinetic energy and potential energy of an object is total mechanical energy. So we find that during the free fall of the object, the decrease in potential energy at any point in its path appears as equal amount of increase in kinetic energy. That's why total energy, that is total mechanical energy, is constant. Thus, there is a continual transformation of gravitational potential energy into kinetic energy. First question, state the law of conservation of energy. Energy can neither be created nor be destroyed. It can only be transformed from one form to another. Next question, why does the oscillating bob eventually come to rest? This is due to air resistance. The bob will come to rest due to air resistance. Next, what happens to its energy eventually? What happens to its energy eventually? Is it a violation of the law of conservation of energy? No. There is no violation of conservation of energy because energy is transformed from one form to another. What happens next? Next question. Question third, an object of 20 kg is dropped from a height of 4 meter. Complete the table computing potential and kinetic energy, and G is given as 10 meter per second square. So in this, height of the object 4 meter, so potential energy will be 800 joules, kinetic energy 0. So total energy is 800. Next, at height 3 meter, potential energy is 600. At height 2 meter, potential energy is 400, then 200, and just above the ground it is 0. Kinetic energy will be 200, 400, 600, 800. So here the total energy will be in all 800. Now this worksheet is clear to all of you. Please like and subscribe if you like this video.